Have you ever wondered what the world is really made of? What if the chair you're on, the air you're breathing, what if even you aren't made of matter or energy, but of pure information? It's a huge idea, and today we're going to unpack it, the theory of informational physics and some of the very latest science that's pushing it forward. So let's just dive right in, shall we? From the time we're kids, we learn the universe is all about matter and energy. But what if that's just the user interface? What if, underneath it all, reality is written in a kind of code, like a cosmic programming language? What if everything we see and touch is just the output of that code? All right, here's our roadmap for today. We're going to start with the basic concept, get our heads around it. Then we'll look at the brilliant minds who first came up with this stuff. We'll see why the first attempts to build a theory kind of stalled out, and then we'll get to the really exciting part, a brand new framework that might just be the key. And finally, we'll ask, so what? What does this mean for us and the future? Okay, so let's get to the core idea. It's summed up perfectly in this little phrase, it from bit. Think about it like this. It is any physical thing, say an apple. The bit is the smallest possible piece of information, a simple yes or no answer. So you ask the universe a question. Does this point in space contain apple? Yes or no? Is it red? Yes or no? The theory says that if you get enough of these bits answers, you don't just describe the apple, you actually bring the apple itself, into existence. And that right there is informational physics in a nutshell. It completely flips our normal way of thinking. Instead of information being something we use to describe a physical world, this theory says that information is the physical world. It's kind of like a video game. Everything on the screen, the characters, the world, it all looks and feels solid, right? But we know it's all just generated from lines of code. Well, this theory suggests our entire universe might be running on a similar principle. Now, I know this might sound like it's straight out of a movie, but this idea has been around for a while, and it's been developed by some of the smartest people of the last century. So let's follow the breadcrumbs they left for us. You can really see how this idea grew over time. It kicked off way back in 1948 when a guy named Claude Shannon figured out how to actually measure information mathematically. That was huge. Then, in 1961, Rolf Landauer found a direct link between information and the physical world. He proved that even just erasing a bit of information cost a tiny amount of energy. So information is physical. That discovery paved the way for the legendary physicist John Archibald Wheeler, who in 1990 gave us that incredible phrase, it from bit. And now, today, this thinking is front and center in quantum information theory, where things like qubits and entanglement are all treated as forms of information processing. So the idea was powerful. It was getting more and more traction, but it had a massive problem. How do you take a fascinating idea and turn it into a real, testable, scientific theory? That was the big hurdle. And people definitely tried. Oh, they tried. There were these incredibly ambitious models that attempted to build a whole new physics starting with nothing but simple informational rules. The goal was to see if you could derive everything, atoms, stars, galaxies, from scratch. But, and this is a big but, these early models all hit the same wall. They were more like beautiful philosophical ideas than hard science. The math behind them wasn't always rigorous enough. You couldn't actually test them in a lab. Crucially, they didn't predict anything new that we could go out and look for. And because of all that, they just never really broke into the mainstream. They were stuck on the outside, looking in. Okay, so that brings us to today, because the story doesn't end there. In fact, this is where it gets really exciting. A brand new approach has shown up, and it was specifically designed to fix all the problems that held back those earlier theories. This might just be the piece we've been missing. So in 2025, a really comprehensive new framework was put forward by Kevin L. Brown, who is an independent researcher, inventor, and author. His work is called the Unified Informational Physics Ontology, or UIPO for short. And an ontology is basically a formal blueprint for how reality is structured. This one aims to provide a solid foundation for the whole field. At the heart of his work is this idea he calls triune harmonic dynamics, and it's all about integrating things that were missing before. It's built on some really practical pillars, using math that computers can actually prove, so you remove human error, building science that is truly testable, with clear instructions on how to do the experiments, and creating models that actually reflect how things work in the real world. The goal is one single framework that can connect everything. So the UIPO gives us a formal language to describe an information-based reality. It uses this formula, IMO. Now, don't let the letters scare you. It's a pretty cool way to think about it.
Imagine reality is a huge ocean. The I, the informational manifold, is the ocean itself, the space where everything happens. The M, the informational fields, are like the currents and waves moving through that ocean. And the O, the operators, are the laws of physics that say how those currents and waves have to behave and interact. It's a formal map for the whole system.
So let's just put it all side by side to really see the leap forward here. The old models, mostly philosophical. The UIPO, it's designed to be mathematically rigorous. Their math was often speculative. This new framework is built from the ground up on new axioms. And here's the absolute game changer. The old models had no way to be tested. Brown's framework actually includes protocols and templates for experiments. It's built to be tested. It's designed to move this whole idea from the realm of what if into the realm of actual science.
So what does this all add up to? Why is this new framework such a big deal? Well, if it holds up to scrutiny, it could change everything, not just our physics books, but our fundamental understanding of what reality even is.
So if you remember anything from our conversation today, let it be these 4 things. 1, it provides that solid mathematical blueprint that informational physics has always needed. 2, it gives us a bridge to get from abstract theory to actual real-world experiments. 3, it's a model that helps explain how all the amazing complexity we see in the universe could grow from very simple rules. And finally, it aims to be a grand, unified system that could potentially connect physics, information, and maybe even consciousness itself.
Which leaves us with one final, absolutely staggering thought to chew on. If this theory, or one like it, turns out to be right, if the universe really is built on information, does that mean reality itself is a kind of program? And if it is, maybe, just maybe, we can learn how to read the code.